Good night for everyone. We're going to introduce ourselves. This is the Integrator project night term of the career telecommunication engineer. The members of this project is Jason Merchant, Mateo Niño, and I, Nicolás Murcia.
The name of the project is Sign of Radio Link Point-to-Point of Communication to transmit the mobile internet services to the municipality of Puerto Carreño Bichada. The topics involved are is antennas to propagation and microwave, mobile communication, generation network, and English. Main object: a point-to-point link to transmit the mobile internet services in rural areas in the municipality of Puerto Carreño Bichada, contributing the economic growth of the region by helping small producers get products together digital platforms. Object. Phase 1. Investigate of geographical characteristics and demographics of the municipality of Puerto Carreño Bichada. Second one. Find according to the rules are which will be covered. One. Sign point-to-point that are used to communication according to the geographic, demographic characteristics and municipality of Puerto Carreño Bichada.
Good evening, I am Mateo Niño, Daideli, Colombian antennas. We create different points of interest on the map, all of the antennas to determine the path of the radio link. There are 86 antennas available. You can start from Barranquilla or Buenaventura, the direct link. We select starting from Barranquilla. Direct link issues. In this diapositive, we have all the tests that we performed to be able to find the route. We had to add two additional antennas to decrease the distance, and since it was difficult to find a route through the mountains and the curvature of the earth. We use these two equations to find the Fresnel. Equation freeze. This equation refers to free space path loss, antenna gains, and wavelength when receiving and transmitting, where PR is potency received, PT potency transmit, GT is transmitting antenna gain, GR is receiving antenna gain, wave is receiving antenna gain, wavelength R is distance. Fresnel at center point. This image is the first radio link. With this equation, we calculate the center point of the radio, where D is distance, total distance, F is frequency, and Fr is Fresnel in meters. Fresnel to any point of the radio. This image is from the first radio, and this equation we find the Fresnel at any point of the radio, where D is total distance, F is frequency, D1 is the distance to the first obstacle, D2 is the rest of the distance to the end of the radio, is the rest of the distance to end of the radio. With this we have 60% of the Fresnel and 80%. So in this diapositive we can find the maximum distance that an obstacle can have at any point of the radio. For this calculation, the height of the first antenna is multiplied by the subtraction of the height between the second antenna and the first antenna divided by the total radio distance link. All of above multiplied by the distance at which you want to know the date maximum of the obstacle. For this project, we make an Excel calculator of the present zone and the maximum distance of the obstacle. Just by changing the values of the antenna and the radio link, the Excel can show the calculation.
Direct link connected, so we show you the last slides. We can show you the difficult we had creating this direct link. So to the end, we create a direct link. You can watch the image on the right side. How we connect the direct link point to point to Barranquilla, from Barranquilla to Bogota. We use 11 steps. This is a direct link. We use a frequency 2 gigahertz, a potency to 43 dBm, and the sensibility of these antennas is minus 110 dBms. Well, when the direct links arrives to Bogota, we use a Claro Air station to transmit the signal to the Intelsat satellite. Intelsat is the provider to give us the satellite, and the name of the satellite that we're going to use is Intelsat 1002 at 359 degrees east. At the left side, we see the connectivity. This is the area of the coverage of this satellite. This satellite works in this area and has some features. This feature is uplink, downlink, channel, bandwidth, and polarization. So we use on the frequency to uplink a frequency of 6035 megahertz. To downlink frequency is 4450 megahertz, and we use two channels. To uplink, we use the 3 channel and 1 channel for the downlink. So the bandwidth for the uplink is 40 megahertz, and the bandwidth for the downlink is 80 megahertz. This satellite have a polarization. That means it's rotating circular and can rotate in the right hand or left hand.
For our tessellation, we are 5 in OP of the sectoral antennas ODI of 3 frequency channels. The estimated coverage is 70% of the population. In the antenna, in the name antenna is ODI, reference 065 R17 and 18JGQ. This is produced at the 3 frequencies between 619 and 916, 1005 and 219 and 1005. La 200 2690 frequency. We frequency of the 1100 megahertz, then located at the altitude of the 13 meters and has covering of the 500 mirrors. And half doubling is the 3.2 degrees, and the sign of the tessellation is 1 to 1. The equation in the radius is 1j2 plus 1 plus 1 times 1 equals 3. Channel factor 3.
Well, conclusion. So, the first one, it is concluded that according to the tessellation carried out, it is important to take into the area wherein the cell and the antenna are located. In this way, better coverage and less use of the resource can be obtained, as in the cell located in the hill. For example, on the tessellation we have a sector, we put an antenna on the hill, and that gives us a better coverage on the area using less sector or antennas. The other conclusion is the geography of Colombia makes it difficult to propagate signal through point-to-point links due to its mountain range. It is concluded that there are areas where point-to-point antennas should be placed to minimize these obstacles, since they do exist those areas. This means, for example, creating the point-to-point link, we found some issues. That issues means the mountains, the curvature, the geography was very difficult. We have to create two antennas in some specific points to try to get a visibility, a direct visibility, and can connect those antennas. That means this conclusion. So the next slide, please. So we share with you the bibliography that we found or we investigate to create this project and this slide. Thank you.